Well, hello everyone, and welcome back to Adrian's Digital Basement 2. On today's video, we have some scintillating content. We got some disk drives, and I'm gonna be testing them in this video. Super exciting, I know, but well, it looks like we have at least 10 5¼ inch disk drives, and then a couple 3.5 inch. These are all drives I've sort of been accumulating over time here in the basement. And I like to test these just to make sure they work, and I like to mark them to say if they are 360K or 1.2, and then if they have the capability, if they're 1.2 megs of running at dual speed. I'll talk a little bit more about what that means in a second, but yeah, let me put this on the ground. It's quite heavy. And let's get started. For testing purposes, I have my test bench here. The test bench, it's my 3D6SX system. We'll just slide this into view actually. So we have it hooked up through a CGA card to the RetroTink RGB to HDMI. We have the XT IDE right here with a compact flash card. That's for booting up into DOS. I do have my post card in there. It's not really needed for this. And then we have a floppy drive / IDE / serial multi-IO thing controller there. And I have a long I have a long floppy cable, and it's got all the connectors on here for hooking up to those different floppy drives. Of course, you need to have both the small one here, that's for 3.5 inch disk drives, and this larger one, that of course is out of focus, but there it is, that is for the 5¼ inch drives. This cable is quite long, which I like, and this one here without the twist, this is for the B drive, so we won't be using that. And this cable has another set of B drive connectors on it, not to mention it has some tape on here because at one point I had a connector here, which I relocated. I probably stuck it on there and then moved it at some point. A rather essential tool for testing these types of disk drives are cleaning floppies, and I have a few different ones here. So 2 of them here for 3.5 inch drives, and then this one is designed for single-sided drives. It's not really designed for it, but I stuck this little piece of plastic over it, so we won't be using that one. I think this Radio Shack disc, yes, it's good to go for the double-sided drives. All of these are double-sided, so that's what we'll be using. And then I have a little bottle here which has 99% IPA in there. This is the first disk drive. Let's see what type of drive it is here. There it is, TIAC FD55 GFR. I'm gonna say that this is probably a 1.2 megabyte drive. And I quickly looked this up, and sure enough, the G in the GFR model number there represents 1.2 megabytes. Now, some of these drives, some of these TIAC drives have a really cool feature that can be helpful with certain machines. If we flip this over and we take a look at the PCB here, there are spaces for all sorts of jumpers on here. Now I'm gonna have to go look this up to see if this is one of the capable drives, but there is often a jumper on these drives that allows it to operate in dual speed mode. So a 1.2 megabyte drive, I've talked about this before, it's an 80 track drive, 96 track per inch, and the spindle, while it's reading 1.2 megabyte drives, or disks that is, it runs at 360 RPM. And that is to simulate or emulate the way 8-inch disk drives are, because when IBM came up with the 1.2 meg standard, they just took the 8-inch disk drive and they shrunk it down to a 5¼ inch form factor. Well, and that's what we have here. And 8-inch drives, they run at 360 RPM, unlike the 300 RPM that 360K or double density disks run at. And also almost all 3.5 inch drives also run at 300 RPM. So the way these drives are normally configured, at least for operation with IBM PCs, is that the spindle always runs at 360 RPM. And when you're reading a double density disk in one of these disk drives, it should be running at 300 RPM. But what IBM did is I guess they like altered the floppy drive controller. Maybe they came up with a special version, or I don't know if they all support this or not. But what the floppy drive controller on the computer does is to facilitate reading a double density disk, which should be read at 250 kilobits per second on a 300 RPM drive. When it is spinning at 360 RPM, the controller can read that disk at 300 kilobits per second versus the 250 kilobits per second that it should be at. The dual speed operation that some of these TIAC drives support is quite useful, because if you're using this drive on a machine that only has a double density controller, so 250 kilobit, that controller generally cannot read or support any drive that is running at 300 RPM. It needs to be running at 250 RPM. But there are certain old computers that use 80 track drives, which is what this is. Remember I said it's 80 track at 96 tracks per inch. A normal 360K disk drive is 40 tracks at 48 tracks per inch. So if you want to be able to use one of these types of drives with one of those computers that happens to use a 96 track per inch, 80 track drive, but only at double density bit rates, you need to run the drive in dual speed mode, or at least run it at 300 RPM. Now, the way that works is if it's supported on the drive, there's a jumper on here somewhere, one of these jumpers you can set and puts it into dual speed mode. And then there's an extra signal that comes from the controller, and the PC does send this. And when it sends the high density signal, the spindle runs faster at 360 RPM to read 1.2 meg disks. And when it's sending the double density signal or no signal, then the spindle will run at 300 RPM for about 250 kilobits per second. So I like to identify if the drive has that dual speed mode and either put a jumper on there, and then I will write, usually on the side of the drive here, that this is a 1.2 meg drive. And then if it's dual speed, I will write that as well. So it helps me identify quickly if the drive is one that I could use in one of those machines. Now, I happen to have a couple computers floating around here in the basement, stuff that I haven't shown on the channel yet, that does use these 80 track or 96 track per inch disk drives at 250 kilobits per second. So the dual speed nature of these is what I'm looking for, and that's what we're going to try to identify in this big pile. One more thing I'm going to talk about here is that often there are many variants of these drives, just like slight differences, and not always is there a jumper available to do the dual speed, or it has a later controller or whatever that doesn't even support it, or it's a different brand. Looks like they're not all TAC drives in this box here. So there are many types of drives that are 1.2 megabytes that do not run at dual speed. There's the diatribe about why the dual speed is important, but of course we need to make sure that the disk drive actually works. And yeah, so in fact, there's 12 drives in this box. Put your comment down below of how many you think are gonna actually work. These are totally untested. I don't even know where these came from. These are all given to me over time. I've just sort of accumulated them in this box. And like I said, we're gonna start doing some testing. So I did a quick Google for the part number on this drive with datasheet and came up with this one here from DeRamp. And there it is, dual speed. If it's running in high density mode, you are good for 360 RPM. And if you're running in double density or normal density mode, then you're good for 300. In single speed mode, like I told you, is how this drive is almost certainly configured right now. Then it will run at 360 RPM in both high and normal, which results, I think we scroll over here, there it is, 300 kilobits per second and 500 versus 500 and 250. All right, here we are zoomed up on the controller. So right off the bat, drive select 0 through 3 are available. So drive select 1 is what you need to have it on for the PC. But if you're gonna use this drive on like another computer that has a normal SugarArt style interface, you would have to set it on drive select 0 typically, or drive select 1, 2, or 3, depending on which drive you want it to act as. Now, when we look at the jumper configuration here, it's not looking exactly the same. And this is pretty typical. So there's D0 through 3 and U1 and U2. It looks like we have a U0 right there and a U1. Okay, so that's the same. It's a little blurry. Then we have these two jumpers here, which aren't in the same position there. Plus it shows this stuff over here, which again, doesn't really match. But what I'm gonna need to do is look through here, which of these needs to be changed for the dual speed. Here it is, speed mode, I, and IS. When the I strap is on the on state, dual speed mode is designated. When the I strap is on the on state, single speed mode is set. And when IS is on the on state, dual speed mode is selected. Like item B, however, the FDD maintains the ready state with no relation to the signal. Okay, I think it's the I strap that I really want to change it to. Is there even the I strap on here? I got to put my goggles on. And there is the I strap. So this right here, I think, is the I strap. There's the IS strap. What I don't see is the II strap, which is currently what it should be set to. Now, without a doubt, when we notice that there are lots of holes in here for jumpers that aren't installed, and I'm assuming that, you could clear these out and install pins if you needed to. And some of these might actually be shorted on the PCB, so you'd have to cut through a trace like right there to break that so you could install a jumper selectively. But as I just said, I don't see the II strap. So I'm gonna try setting the I jumper right here. Hopefully that overrides the II or default setting. which is just not currently available here. Remember, looking back here, on some of these drives, you have this little T configuration with I, and IS. So there would be a jumper there on II, and you just move it to the I setting, and then that should set the dual speed mode. Do remember though that if you are trying to use this on a normal IBM PC, you should set it for single speed mode the way it is by default. And the reason why is the PC does expect it to be running at that 360 RPM or 300 kilobits per second while you're reading double density disk. That's just the way DOS is set up to work. So that's the way you have to have these drives set. But as I said earlier, I like to identify if the drive, well, A, works, and then B, runs in dual speed mode, and then I can mark it as such. And if I ever do use this on a PC as just a normal 1.2 meg drive, then I will set it back to, you know, single speed mode. I do recommend though, by the way, if you're ever reading double density disks, or especially writing those disks on a PC, you shouldn't even use one of these disk drives. You should really use a 48 track per inch drive. The reason why that matters, and again, I talked about it in my disk drive video, I'll link to that down in the description below. The reason why that matters is because when you write onto a floppy disk using the 48 track per inch head, the lines that get written down, the tracks that get written down are wider. And the 96 track per inch head that's on here has just a much finer pitch when it writes the circular tracks. Now, generally on a blank disk, if you created a 360K disk on a drive like this, then it would read back without any kind of issue on a 40 track drive. But if you have a disk that was written before on a 40 track drive or a 48 track per inch drive with a thicker, wider heads, when this tries to write to it and erase the heads, it's not really going to be able to erase the entire width of the track. So it's going to write down the new track in the middle of the old track. It's going to have like some of the old track in there and some of the new track, and that could possibly cause issues down the road. If a drive like this is the only drive that you have and you need to write a double density disk, I recommend what you do is you degauss the disk first, so it completely erases it and removes all the tracks from it first. Then you can write it without any issue, read and write it in a drive like this. But if you're trying to read and write a disk that was previously used on a regular 360K drive, I really don't recommend it. You can read it, but I don't recommend trying to write to it. And there's one other thing to consider also, by the way. If you're making archive copies of a 360K disk, they just work better in 360K drives running at the correct 300 RPM than in a drive like this. So the disk images you create in a high density disk drive at that 300 kilobits per second are much more difficult to write and deal with when someone is trying to create a disk later on an actual 360K drive. So anyways, okay, that's enough going on. Let's plug this into power. And let's see, it's a bit dusty, this drive, but let's see if this thing can work. Alrighty, what I'm gonna do is I'm gonna boot up the system there. Hey, it's seeked, so that's something. I have it set for 1.44 megabytes there. It doesn't matter. I'm going to be using IMD for testing this drive, and IMD controls the disk controller directly. So it doesn't matter at all what the BIOS is set to. In fact, you could have the BIOS set to no disk drives, and IMD is still going to be able to talk to the drive without an issue. So we're here in IMD. I just need to set this up for this drive. So it's a two-sided drive. Double step is going to be off because this is an 80 track drive and it does say 80 right there. That stuff doesn't matter, and we'll just put this as 1-to-1. And now what we can do is we can hit clean head, and we can watch to see if this is actually going to move the heads properly. Sounds like it's working fine. What I'm going to do is we're going to put some of this IPA on this cleaning disc here. Look, it's spinning properly, so that's a good sign. Now we'll just let this sort of go through a cleaning cycle here. We'll do that one more time. It allows you to do it up to 9 times, but you know, doesn't really matter. I'm gonna grab a high density disk and we'll see if it can read it. All right, here's a disk, it's high density. It does say to test, so I'm assuming I will have formatted this disk. Not 100% sure. Okay, so we go to align and we hit enter. And what this is gonna do, okay, so it's reading the disk without any issue. So that beep is, it's reading 30 tracks. So this has a 15 tracks per, or 15 sectors per track, but it's, I don't know, this program just shows a 30. I don't remember why. And if we hit like 1, that goes to track 10, 20, 30. Now, if it weren't reading the track properly, or say, watch, if I slow down the spindle here, see how it's just There we go. So it's giving, you know, issues there. Then you'll have lower numbers. It should be a consistent 30 on every track. And this, of course, is formatted, this disk is formatted in another machine with a known working drive. So here we are on track 70. You should be able to jump around the disk and read, oops, I went to track 80 there. Track 79 is the highest. So I'll hit minus, and now we're on track 79. It's reading properly. It's reading on head 0, so the bottom side of the disk. If I hit H, now at the top, you can see it says H1. That means it's reading from the top side of the disk. So yeah, it's working. It's normal for it to make a weird beep while it seeks, because as the head's moving, it's gonna miss a few sectors. If the head were out of alignment, watch, I'm gonna put this on 3 and then I'm gonna move the head. Watch what happens. So notice how the beeps changed and it says 0 and 30. So what it's saying is that it's still reading 30 sectors off the disk, but it's expecting it's on track, what, 34, and it's reading 30 sectors or 15 sectors from an adjacent track. If I move the head back, there we go. Now it's back on the correct track. And if I move it here, it's wrong again. And what you can do is hit recalibrate. It goes back to the 0 track because there's a sensor, and then, yeah, so we're good. Going back to the main menu here, we hit test RPM, and with this disk in here, we should see 360 RPM. And there it is. It's about 359. It's settling in 500 kilobits per second. So it's definitely in the high density mode right now. I want to see if this thing is actually running in dual speed mode right now, because I have it set that way. Let's grab a double density disk. It does need to be one that's formatted on another machine. I don't know if this disk is or not. So let's do test RPM. And what it tries to do, tries to read the disk to see, you know, what bit rate it's running at. Yeah, I don't think this disk is formatted. But just to make sure, what I'm gonna do is I'm gonna format this on my PC over here on a known good 360K drive, so I have, you know, known quantity to start with. All right, the disk is formatting in the other machine over there. One thing I'm noticing is it doesn't appear that this drive is actually running in dual speed mode. And the reason why I say that is because you can usually hear it sort of change speed when I hit A for analyze. I'm gonna pop the cleaning disk in. When I hit A for analyze, we should be able to hear the tone of that like scratchy sound of the cleaning disk change frequency as it changes from 250 to 500, and it's absolutely not changing at all. It's staying at exactly the same speed. You can absolutely hear it change speed as the bit rate there changes from 250 to 500 to 300. So what I'm gonna do is I'm gonna pull this jumper off here, and we are gonna install the IS jumper here. Okay, let's try that one. Analyze. No. That is not doing anything. Now thinking about this, one of the potential issues is that the floppy drive controller, which I'm using here, let me pop it out of the computer. This controller, I don't normally use this one, and it may lack that density signal altogether. So we're gonna switch to a controller that I know has the density signal, which is this one right here. This is a controller that I've used many, many times on here. And just as a side note, this is the one that I accidentally damaged the ROM. I killed the ROM on it, and this allowed the jumpers here to use different floppy drives on an XT, so you could use high density drives on an XT. A viewer reached out to me here and found the ROM image. It's not exactly the same ROM image that I had on this card originally, because this one used to display a message that said like 1.44 meg disk if you had it set for 1.4. But on the other hand, this ROM does work. It doesn't display a message, but it works. So yes, thank you very much for sending that over. I've had it for a while, and I just finally got around to testing it. So let's see what's gonna happen. So if I go into the BIOS, by the way, and I, you know, have this set for no floppy drive, like, there we go, not installed. Because that card has a ROM on there, it is still gonna actually try to initialize this disk drive. See, there it goes. And it did the seek and everything. All right, while it boots up, this disk is now formatted as a 360K, so we are good to go. This drive does work, so that's a good sign. Let's go to IMD again. Okay, here we go. Let's do analyze again. Nope. That is not changing speed. So I'm gonna try setting this jumper, error out of course, because there's a cleaning disk here. I just put it back on the I setting there. This may not be able to do the dual speed. Let's try alignment one more time. Oh, there we go, it's working. Yeah, okay, cool. So that other controller doesn't support that signal. Now, that doesn't matter because for the PC, you don't need that signal. So let's exit out of here, by the way. And let's pop in the formatted disk. Now, like I said, on the PC, you don't need that signal anyways, because if you set single speed mode, then the drive will just run at the same speed all the time. So if we go to alignment here, we should be able to read this disk. Yeah, I hear it changing speed. So there we go. There we go, 250 kilobits per second, and it is currently reading 18, which is correct because it's 9 sectors per track. And the difference is, watch this, if I hit plus, we get nothing because remember, this is a 40 track disc and this is an 80 track drive. So it's in between the two tracks right now. And if we hit plus again, we are on what the drive thinks is track 2, right? Because we had a blank track in there. But what's happening is it's reading what is track 1, because remember, there's only 40 tracks on this disc. This is excellent. This means that this drive is working. And if we test the RPM now that it's in dual speed mode, it will run at 300 RPM, and that's with this disc in there. Here it goes. There it is. So the RPM takes a little while to stabilize with this program, but this is a working dual speed drive, and even though it's very dusty, as is normal for these TX, it's very reliable. I've had a few of these TX die over the years, but this one, wow, this is a working drive. Awesome. I'm just going to write on the side here, so 96 TPI, right? /80 tracks, of course. And then the other important thing is this is dual speed. And I'm just gonna write somewhere on here, JP is I. That's the dual speed jumper, just to remind me. And it gets a tick mark because it freaking works. Just needs a little bit of a clean, but I won't do that in this video because it just needs to be dusted off. Maybe a little drop of lubricant or whatever on the slider there. Although with the power turned off, yeah, this thing moves very, very freely. So cool, good drive. That's one down, and there's like 12 more to go. I will go quicker because I don't need to talk as much. Let's grab another TAC drive because we'll go to the other brands in a second. Okay, so GFR. So I think this is the same drive, and it's in cleaner shape. The jumper situation is exactly the same. So I'm gonna get a little jumper, and we're gonna put it on the eye there. Yeah, this jumper's too big. I need to use a low profile one, low-ish profile. There it is, the eye jumper. And we're on drive select 1, which is, remember, correct for the PC. And this thing, as I said, is in nice shape. Okay, so heads move freely. Let's power on the computer here, and we will put the cleaning disc in here. This cleaning disc is getting a little ratty. We'll switch the input to one that you can see. There we go. Let this boot up into IMD again. I don't even know why I shut the power off. To be honest, I unplug and plug the cables on these drives all the time while it's powered up, and it doesn't really matter, at least with this controller and stuff. From a termination perspective, I can't remember if you can disable the termination with a jumper. It might be possible, but I think these terminate the floppy cable, not with 150 ohms, which they should be terminated with. It's something more like 10K or 4.7K or whatever. So if you add two drives together and they both have termination resistors, it just adds up and it's not that big a deal. If it's terminating with 150 ohms like it should, when you connect two drives, you're now at 75 ohms, and that means that the floppy drive controller has to push a lot more current than it would normally at 150 ohm, and you're kind of out of spec at that point. So at that point, you should have termination on the last drive only. Some of these drives have a T resistor here that allow you to disable the termination. Sometimes it's a little chip you have to remove, but sometimes it's actually a jumper. Now, 3.5-inch drives, I've never seen any termination jumpers or anything on those, which kind of sucks. Okay, we're gonna do clean disk 3 times. Let this run through the cleaning cycle. Okay. That's weird. This drive is acting like it's a 40-track drive. See how it's like bumping into the bump stop there? Well, that's weird. I thought it says GFR on the back there, which I thought that meant that it's a 40-track drive. Double step is on. Okay, well, there's my problem. I made a mistake right here in the settings. off. So now we do clean. I'll just do one cleaning cycle. This should do it properly. Yes, okay. Okay, there we go. So we're good. Let's go for the 360K disc right here. Let's put this disc in here and we do analyze. Oh yeah, I hear the dual speed working already. So that's awesome. There it is. It's looking good. So remember, I can't really reliably read this disc though, because if I go to like track 80, I think we should find a valid track around here somewhere. There it is, reading track 39 off this double density disc, even though it thinks it's on track 78, but that's as expected. Okay, so that's working. I already know the dual speed's working because it was at 250 kilobits per second and it was reading the disc correctly there. Let's put the high density disc in here and we'll just do the same thing. Now, I don't really do much more than what we're doing here for testing these drives. It's all you really have to do. Yeah, there we go. Now we're looking good. Track 10. I'll just quickly go through these. Go to 60. We're at 70. Jump back. Just make sure it like is, you know, falls accurately onto the correct track. If this mechanism were gummed up, then what would happen is when you move back and forth, it would like fall into the wrong track, and you know, you'd be able to tell that right away by this. Hit H for the other head. It's looking good. Yeah, okay. So we have another working drive. And that is freaking great. And it's dual speed as well. So there we go. I'm just going to write it as dual speed JPI, 1.2, you know, megs and 9680. So yes, that's how I should have put it. I usually like to write if it's a 360 or 1.2, just as I'm quickly looking through the drives, I can find it. Sweet. Okay, we have another working drive. So that's 2. Okay, here is the next one. This looks, is this a TIAC? Yeah. Looks similar to the other one. It's the first one, that is. This has some drive rails on it. These look like they're from a 5170 actually, so that's kind of cool. Looking at the back, we should have the old GFR, and we do. This number looks different though, so the PCB on the bottom is probably going to look a bit different, and it doesn't. I think it looks it looks basically exactly the same. So we're going to do the same thing again. Boy, this is kind of repetitive, but hey, that's how it goes, right? Let's zoom in, and I will use my camera to see the eye jumper. There it is. There is the eye jumper. Boop. So there we go. Drive select 1. Just make sure that's correct. Otherwise, you might have a non-working drive. We'll plug in the floppy cable here, and we'll plug in the power. Okay, power's connected. Now what we're going to do is press exit out of that. We're going to use the cleaning floppy like we've been doing. Incidentally, you can put more IPA in those little zones right there. Okay, we're gonna do C, cleaning. I didn't even check to see the head was moving correctly, but that seems to be working well. As this cleans, I'm gonna grab another drive here. We got another TIAC drive. There's a bunch of, there's a couple other brands. Wait, oh, that's not TIAC. That's not TIAC. And that's not TIAC, okay. Okay, but here's another TIAC, so we'll do that one next. So that sounded good. Let's go to this drive. That's the high density disk here, so we'll go align. Now, when it comes to like RPM and stuff for these TIAC drives, it's not even adjustable. There's a servo motor with a sensor and everything, so it's always going to be correct. It can compensate, like if you try to put drag on the motor, it compensates perfectly until it can't anymore. It doesn't have enough torque. So we're looking good here. And yep, and we hit head, so both heads are working. Back to 2, looks good. Let's swap over to 360K, align. I can hear it changing speeds, so that's good. There we go, it's good. So we'll go to 70 here. Okay, and it's reading track 35 when it should be reading 70, so there you go, it's half. And if I put it in dual step mode, I think it will work. Maybe not in the alignment thing though, I can't remember. Let's just, for grins, we'll just test that. So we're gonna hit double step on, and we're gonna go back to align. And let's see if this now reads correctly, you know, where the tracks aren't misaligned. Okay, so we're gonna hit 3 for 30. No, so he still thinks it's on track 30, but it's only reading track 15 off the disk. And that's because this mode, it doesn't double step. It kind of ignores that setting. Okay, there's a way to do it. S, you push the S key in here. Okay, so we're gonna hit R for recalibrate. There we go. Now it's working. So it thinks it's on track 30 because it says T30 at the top, and now it's actually in the correct position for track 30. And if we hit 40, it's not gonna work, but I'll have to hit minus for 39. Yeah, we're good. Okay, so that, like I said, you can do double step in here, you just have to do it separately. All right, so we have another working drive, so that's cool. I should take these off because I don't need those on there because it makes these harder to stack. I like to kind of stack these up on their sides and having this little rail on there, which of course I will keep because I don't even know if this, is for a clone or what, but get off there. But I'll put them in my little bin. I have a little bin that I keep full of like things like drive rails. Now, incidentally, I did design a 3D printable drive rail. I did this really early on when I first got my 3D printer years and years ago, and it's on Thingiverse. So if you do need a 3D printed drive rail, you can make your own. Okay, there we go, dual speed JPI. TAC drives, they rock. So we're up to 3 that work, and all 3 are dual speed. Okay, so this drive here is in a bag. Does that mean it's unused? Oh, I don't think so. This is a Ziploc bag. And wow, so this does look a little different. It is a TAC, but notice this PCB here is much smaller. The other ones are kind of like extended further. Does this move? Oh yeah, the whole head thing looks different too. What is this? It's still a GFR, so it's still a high density drive. Oh, okay. I think this is one of the ones that doesn't support dual speed. Look at this PCB here. DC, that jumper is on the other ones. There's the U1 jumper. Where's the freaking drive select settings? Oh, wait, look. Yeah, drive 1, drive 2, and drive 3. There's no drive 0. It's right there with no... Oh, okay, yeah, I see. So that pin right there is drive select 0. So you move this jumper over to get drive select 0. So that means it still can work on one of these older machines. But let's just take a look and see. I mean, obviously there's no pins installed. So yeah, something to do with the ready and the disk change signal here. The U1 is there, although, oh, that's IU. So I wonder if that's a dual speed jumper there. We're gonna try that. I don't know what E2 is. Either way, this looks a lot different. And look at the year here, 1993. So let's grab a jumper. We're gonna see if this IU jumper right here actually does the dual speed. So here we go. This is a high density disk. It is not changing speed. Oh, I put the double density drive in there. Okay, so see how it's running at 300 kilobits per second? So this is a single speed drive. All right, well anyways, there we go. So our first working 1.2 meg drive that is not double speed. That's a bit of a bummer. I really do enjoy those dual speed drives. Okay, I've been writing on this side here. I'm gonna put single speed here. Now, if you happen to know how to run this in dual speed, like you saw something on there that I missed, let me know, please. 96 TPI / 80 track. All right, that is the 4th drive now. Is there another TAC in here? I think we have a couple more TACs. Here's another one, and it's in a Ziploc bag, just like the other one. Okay, so this one, can't see it yet, but this looks like one of the older ones. It's got the bigger PCB here. Heads move nice and smoothly, no issues there. And I think we're gonna have the dual speed. Yes, we do. I got the jumper here. Let's zoom in on this. Where is I? There it is, right there. I'll get that on there. Oh, what's going on here? I think there's a bent pin. Oh yeah, there is. Okay, that should do it. Okay, there we go. It's on there. It's a little crooked. Zoom back out, flip this over, hook up the power. Just make sure you don't force it on the wrong way because obviously the power supply is energized right now. Connect that. We're gonna get the cleaning disc. Everyone knows the drill at this point. Pop a little bit of the IPA in there. There's a good chance these drives don't even, it's making a weird noise. Okay, clean. 3 steps. Okay. This weird noise by, I don't know, just had a little resonance sound there, but I don't hear it now. Okay, while this does that, do we have another TIAC? No, we do not. I think that is the last TIAC drive. The rest of these, nope, the rest of these are different brands. Okay. So there we go. Head should be clean. Let's hear the dual speed nature of this thing. It's kind of making a clicky noise. Ooh, I'm not sure this drive is working properly. Yeah, no, I think there's a problem here. It's not reading the disk either. All right, first drive we're gonna have to try to look into here to see what's going on. I'm thinking there might be some crap on the heads. I mean, that really looks fine. I don't see anything on there. But I'm gonna try cleaning this manually here. See if there's just junk on there. Okay, we got with a little like cleaning stick here. What can happen is if the heads get kind of clogged up with magnetic material from bad discs, that can cause issues. I know you're not going to be able to see very clearly what I'm doing here. I'm just trying to carefully just ensure, oh no, the heads are like really clean. So I'm not sure what's going on exactly. Yeah, I don't see anything. There's like no weird residue or anything on there. I'm going to put my microphone near the disc so when I close the drive, listen to the sound it makes. That is definitely like an unhappy drive sound right there. Let's try testing the RPM here. It just sounds like it's not working correctly, and I couldn't tell you why. Look, it's not even able to test the RPM. Let's see on the bottom what we see. So there could be caps. I mean, there are a bunch of caps on here, though they could be problematic. I'm just gonna double check that the rest of the jumpers are correct. Do they match the other drives? That's the question. We have 3 other drives that have the exact same controller as this. Oh, scratching the thing. Yeah, everything is configured exactly the same. So I don't think it's that. Now, one thing I'm noticing is look at this little box here. It's like covered in some kind of gunk. Now, you might think it might be like a leaky cap or something, but the caps, they don't look like they've leaked. And the whole drive's in pretty good shape. So we're on drive select 1, so just make sure that's correct. These caps here, they seem okay. I mean, if you saw like brown gunk and stuff, that could be a problem. But this machine, this drive here, obviously is not reading anything. Okay, so this cable right here is the speed control cable. Make sure it's in there correctly. This is for the heads, and the heads are seeking, so we know that's not a problem. Program is complaining there that we have a non-formatted disk. And here, I'm gonna hit the speed. Oh, it's running at a slower speed there. Faster speed. Now, when we look at the heads here, this is the cabling for the heads. Let's take a closer look with the zoom lens there. All looks correct, like it's connected correctly. So nothing looks out of the ordinary. Things look okay as well. Like there's the spring right there. This is for the spring tension, which is absolutely required for that to work. I'll grab another drive. We'll just compare the way the spring tension is. So this is another drive, and you can see there it's in that same little notch right there. And on that one, yeah, it looks the same. It's in the same exact little notch there. I think I'm gonna have to mark this drive as a future repair attempt. And I have to be honest, everyone, I've never had any luck repairing drives. I've had like the odd TIAC drive not work like this one. And I've never really figured out what was the problem. They just were like doing, actually, I think the one I had was doing exactly like this. It just was running, but I wasn't getting any signal in the computer. Now, I know a lot more about, using my oscilloscope, my analog scope, to try to like read the signals and stuff on this. This is where the heads are connected. Problem is with this drive, the older drives, it's really a lot easier to work on the sugar type drives, like the old full height drives, because they have discrete components. But on this, everything is in this one chip. The heads are red and they go into there, and that's it. If the amplifiers in here are bad, then you're out of luck. Then that thing is just totally dead. And the only thing I want to see is, what is this blue part that's all gunked up looking? Looks like it's some kind of capacitor. It's got a C marking next to it. So that could be the problem, although the fact that it's over here probably has something to do with the head stepper assembly, because as I said, the heads are connected right here and the traces just go straight into this IC right there. All right, I think I'm just gonna mark this as, I'm gonna put an X right here and say no read. And we can take this writing off if I get this thing working. Let's get this floppy out of here. Pop that off, pop that off. Does sound, like I said, it has that weird high-pitched noise, which kind of indicates that there's something going on with the heads here, but everything looks fine. All right, first drive down. So we're at 4 drives working, right? Or 3 drives working. Yeah, we're at 4 drives working and 1 not working. Next drive is this one. I just grabbed a random drive. It's in an anti-static bag, so that's nice. This is, well, it's got a light color bezel with a dark lever on it. That's kind of cool. Bit unusual. Someone wrote P on there. Who makes this drive here? Chinon. This is a Chinon drive, an FZ506. Very common drive. I am 99.9% sure that this is a high density disk drive. So it is an 80 track, 40, 96 track per inch. Look at this, everyone. Look at the carnage right here. What the heck happened? How did this even happen? Those are like, I don't think they stick out unless someone like was angry and like ripped this out of a computer. I don't even know. Wow. I think what I need to try to do is loosen this PCB up, bending some of those pins back, because they don't look happy the way they are there. All right, there's that cover off. And there is the PCB. Maybe there's some writing on there. We can tell what these are. Oh, look at that, you can. So I think TM is Terminator. We got the drive select here. And there's like the DC, disk change ready, MS1, MS2. But we could definitely see some serious damage that's occurred here. Okay, so I'm gonna try to bend these back somehow. There's a jumper there that's been smashed. All right, there we go. It's not perfect, but should be good enough for getting jumpers on. Let's see what that first jumper is. That would be TM, so Terminator. I think this has a selectable Terminator. So we're gonna put the drive select 1 jumper on, which these are the little jumpers, by the way, like are on hard drives and stuff like that. All right, so we are left with U1, MS1, drive disk change ready, MS2. Now, I don't know if any of these support or, you know, any of these will facilitate dual speed operation of this drive. I'm just gonna run this, I think, with the PCB off here. It's gonna be easier for me to try to get jumpers on and off of there. I happen to have some of those little small jumpers in my little, wherever it went, that little thing full of jumpers. So let's plug this in to the system. This is fine the way it is there. It's held up enough. It's not gonna short on anything. Back to this view, and well, we gotta do the cleaning disc, don't we? So let's grab the cleaning disc. I should see if this, we heard the head move, so I think it's okay. We'll find out in a second. Pop this in, spinning. Okay, C for cleaning. It's definitely an 80 track drive, so high density. Well, I mean, it might not be high density. Still, you can have 80 track drives that are only double density. We'll figure that out briefly or shortly when we try to read this disc here. Okay, so that cleaned, all right. Oops, knocking everything over. This isn't even in the view of the camera. So alignment. So this is high density disc. So if it's working, no, it's not freaking working either. Interesting, interesting. Set the wrong, says 250 kilobits per second, but it's not able to read anything. Now it is selecting the drive, The light's on, so that's a good sign. That means the computer, if I hit escape, the light went off and it stopped spinning. Now I may need to try to find some manuals here, but I kind of remember the drive select jumper that's there was another jumper over here. So it may well require something else that's not on there. So what I need to do, I am just losing track of everything right here. Where is my little thing of jumpers? The lid is right here. Okay, found it. And here are some of the small little mini jumpers that it needs. I think these are the right ones. Now, what I'm trying to do is look at the other drives here to see if there's any others that are like this, and I can copy the way the jumpers are configured. None of them are, but I think I have a drive, a Chinon drive like this. I'm gonna go look for it. Ooh, no, I don't have it handy. I know I have one of these drives. I think it's inside one of my computers. So I think what I'm just gonna do is put jumpers on it randomly. I suppose I should just do some Googling and try to figure out, you know, what the jumpers are. But let's put one on the DCRY pin. Okay, there's DCRY. Let's see if that made a difference. Nope. Now, as I was saying, when I first saw those smash jumpers, it looked like there was a jumper over in this area over here. I don't know if it was just like a placeholder jumper. Okay, I put one on that strap, whatever that is. Line. Oh, it's running in dual speed mode now. I could hear it speeding up and slowing down. Let's put in the double density disc now that it's in dual speed mode. No, it's definitely not reading anything though. Let's try one more time here. Oh, it's reading. So, okay, so I'm pushing S, so we're gonna hit recal, so it's gonna be in double step mode. So it's reading the double density disc correctly, and it's running at 300 kilobits per second though, which I thought it was dual speed, but if we go to the test RPM here, it will be at 360 RPM. But I can hear it changing speed. But I think what it's doing is I think it's in the wrong speed. So I think what it's doing is it's reversed. So it's running at 300 RPM in the high density mode, and it's running at 360 in the low density mode. So that's fascinating. The TIAC drive had a setting for like that reversal thing, but did this one have that setting? Let's pop this jumper off. I think it was this last one I put on here. So it's still reading the disc. Let's try again. Yeah, it's not running in dual speed mode now. Okay, so it's reading this disc. So why isn't it able to read the high density disc? Now that it took that jumper off, it's not running in dual speed mode. This is definitely an 80 track drive, but and it's running at 360 RPM, so that means it's gotta support high density mode, 500 kilobits per second. But no, it's not able to read it. Unless there's another jumper that I need to set. Like maybe there's that high density signal's not getting through or something like that. All right, so the jumper that seemed to be double speed was MS2. And then there's an MS1. Let's put the MS1 jumper on. That could be the dual speed in the other direction. Oh, you can't see anything. So I put the other jumper next to the ready one there. Let's hit test RPM. Oh, it's not even spinning now. It's selected, but the motor's not spinning. Let's get that jumper off of there. So MS1. Oh, you know why it's not spinning? Because there's no disk in the drive. Come on. Okay, it's running in double speed drive mode, but it's in the wrong mode. So I'm gonna put that so let me put this jumper back on, MS1. So MS2's on there as well. They're both on there. Let's see what happens now. Okay, there we go. This is the high density disk, and you can see there 500 kilobits per second. It says double density, but you can ignore that. That's just, it is double density, but it's running at 500 kilobits per second. So if we do A for a line, we should be getting the correct track reading here. Sweet, it's working. Let's do heads. Okay, both heads are good. Track 70. it's working. Okay. Now, if we put in the double density disc, seems like when you have MS1 and MS2 on there together, I think we're going to get double density working here at 250 kilobits. Yeah, I can hear it running slower at the 250 now. No, that's a lie. Oh, I see what's happening. Okay. This drive seems to... No, I don't actually see what's happening exactly. Definitely sounds like it's running at the correct RPM. See in the settings here, 300 to 250. Let's change this. Let's see if that... I don't think that has any effect on the analyze mode though. No, but it's stuck. Let me make sure I have the disc in correctly. So this is the double density disc and it was in the correct way. Let me take off this MS2 jumper. Oh, look at that. No. Now it's... That's not right. Is it? Let's try that again. Okay, it's not running in double speed mode now. Now it's just running at 360 RPM. It's running at 300 kilobits per second there. So that's reading... Oh, got a phone call. All right, that was a phone call. I got to go outside just a second. Let's see if this is working. This is the high density disc. Okay, so it's working. I'm going to pause the recording and I'll be back. Alrighty, I am back. I was outside. I had to do something out there for a second. Where did we leave off? I think we left off with this drive fully working with both high density and low density. Okay, so there's the high density drive working, or disc that is. And let's go to the double density disc and let's see if this works. So I think the double speed nature of this is not going to work well, specifically because it seems to be inverted from the way that the TAC drives are. So when this thing is trying to read high density instructed from the controller, let me just get this started here, then it's running at 300 RPM for high density, which is wrong. And now it's running at 300 kilobits per second. So it's still running at 360. So it seems like what's needed on the jumpers, let's flip this down. So it looks like what we have on there right now is MS1. So I currently have the TM jumper, oh, you can't really see it. TM jumper right here is set. DS1 is set. And MS1 is set. And so is this DC-RY jumper. I don't know if that one's really needed, but here we are. We can kind of see it there. So TM jumper termination, DS1 for drive select 1, and then we have MS1 and then the DC. There's still this one more U1 jumper, but I don't really know how that works. So I'm going to leave this as is because it's functional. I just need to kind of put it back together. And yeah, we have a working drive, and it's kind of got the cool light color look, which I kind of dig. It'd be nice if this was dual speed. It's nearly a dual speed drive, so that's a bit of a shame. So we'll get that off, get this off so I can put this all back together. That's an extra jumper. All right, the cover's on. So that is one working drive. But as for the double speed, it almost wants to work, but it doesn't quite work. So if you happen to know how to configure this thing for the double speed to work in the correct way, let me know, because I would like to have this as double speed, but luckily I have enough of those TAC drives anyways, so not a big deal that this one doesn't quite work that way. Alrighty, so the count is up to 5 working drives and 1 drive that does not work. Now this drive here is brand I don't quite recognize. We'll look at the back in a second to see the label. Let me just get these screws off the side here. Okay, on the back, we got a Panasonic JU475-4, AKJ, that is. And how do the jumpers look? Ooh, it's, this is a dirty drive. A dirty, dirty drive. So if it works, I'll have to do some more cleaning on this thing. Oh, look at that. What a mess. What a freaking mess. This thing was obviously in some kind of a computer that definitely was a dust magnet. Okay. Anyways, it looks like it's got a little bend there. Just a bit of damage, so to speak. Let's see what we can see from a jumper perspective on here. All right, we got all sorts of jumpers there. Kind of hard to tell what they are though. Drive select. I don't know. We'll just go with the fact that it's probably in the stock configuration. This looks like a termination. That's a termination resistor, I think. Are these little capacitors there? Little tiny caps? No, those are test points. Look at those test points. How freaking fancy is that? Oh, and there's a whole bunch more jumpers right here. So almost surely this thing supports dual speed mode. But wow, wow. Oh, that's just terrible. It's interesting how the mechanism there kind of reminds me of a 3.5-inch disk drive, doesn't it? But look at this. That's gross. All right, let's do the cleaning disc. Well, we got to plug the power in, right? Plug in the power first. Sounds like it's doing its thing. Lots and lots of IPA. I don't even know if there's an 80-track drive. We'll find out if it's banging into the bump stop. It's working. And it's an 80-track drive. Sweet. So there we go. It's battle hardened and dirty, but it does work. Now, I'm not going to look for the data sheet on this thing to see if it's running in dual speed or not. But I guess if you happen to know that this can run in double speed, let me know. That's another working drive, even though it's dirty as all. Next up, who makes this? This is a Neutronics drive. All right, so they made the mechanisms in the Commodore 64 1541s. Probably has, yep, they look just like this. This is yellowed, but they're, of course, a dark brown color on the Commodore. But Neutronics, yeah, they make pretty reliable drives. In fact, gosh, look how bad the top looks. Just gross. Let me get that. Let me find I have a cloth here. I want to just see if I can clean that a little bit. Because if that's dirt or rust. Let's see. Dirt or rust, everyone? What do you think? Looks like it's rust, I guess. Well, looks like it's both. Combination of dirt and rust. Anyhow, as I was saying with the Neutronics drives, and it does say Neutronics right there as well, I found these to be really, really reliable. I have a 360K Neutronics drive. It's a Sugar interface, so it works on PCs, double-sided. And when I have discs that are marginal, what I did at one point is I was trying to archive some discs, like, make some backups. And I took a marginal disc and I tried all my 360K drives, like the different brands, TIAC and Neutronics and stuff like that. And I found the Neutronics drive, it just was able to discern more bits and read that disc, that marginal disc, better than all the other drives I have. So I actually marked it as like my archival drive, and that's the one I use. Now this one, it says it's, there's the model number right there, D509V. High density or not, I don't know. We'll just have to plug it in and see what happens. It's very dirty inside, wow. Look at this, filthy, filthy, filthy in there. Does the head move okay though? Oh, that's not happy. I'm gonna have to try to clean this a little bit before we start with this one. It is moving, but it sounds very unhappy, scratchy sounding. Let's get this cover off. Okay, cover's off. Yeah, that is a dirty drive. Whoa. I'm just gonna go and spray some compressed air in here to blow this dust out. I'm gonna take it outside to do that though. I don't wanna put all that nasty dust into the basement. Yeah, look at that. Blech. All right, we are back, and it's not perfect because I didn't use a brush. I just used a can of compressed air, but it looks a whole lot better. Now this does still actually move without issue, but I'm gonna put a little bit of bearing oil on it. There's some bearing oil here, just to kind of hope this slides a little better. Where are the bearings? There's the bearings right here. So a little bearing oil right there. Other side is just slides on it. There's no bearing. And I can see here, there's another bearing. We'll just put a little drop right there and move this back and forth. Oh yeah, way smoother right now. That's way better. Okay, time for the disc. All right, Neutronics, you're a good drive. You're totally a good drive. Yeah, this is a good drive. It works. And from a jumper perspective, we didn't really talk about that. Let's look at the jumpers here. So there's the drive select jumper. It's on DS1. And you notice there are these jumpers over here. So it's possible it supports some kind of like double speed mode. I don't know. Let's flip it over. The connector here looks okay, but it could be the other side that's really dirty. Does this have any info here about jumpers? Not really. Anyhow, it can be really hard to find the data sheets for these like exact drives. This exact model number, which was, as we said, if we can get this to focus, D509V. If anyone can find the data sheet or service manual for this drive, and then maybe we can like decipher if these jumpers here will allow a double speed or dual speed mode, then let me know. I have a feeling that that is not the case and that this thing will only run in single speed mode. All right, I'm not gonna put the cover back on at the moment because I need to do more cleaning, but I'll do that afterwards. We can write on here that this is a good drive though. So I'm gonna put 1.2 and a tick mark. And obviously, we'll just write 96 TPI. I mean, it's kind of funny. When I write 1.2, it's kind of a given that it's a 96 track per inch and 80 track drive, but I like to write it on there anyways. Okay, so that is another working drive. We are up to 1, 2, 3, 4, 5, 6, 7 working drives. One non-working drive. We had one that was finicky. And this, who makes this? This drive's in nice shape. Oh, someone wrote something on the side here, but it wasn't me. It's an Epson drive, an SD600. Pretty sure this is a high-density drive. That kind of sounds familiar. Oh, so this one, okay, take a look at this, everyone. This has got an old termination resistor on it, so you just take that out, and then that will, you know, take away the terminator. So I'm thinking, this is the drive select there. It's on drive select 1. Then we got these straps here, S1, S2, and S3. And those and these, and there's even one over here. So lots of configurability with this particular drive. Closed up, so I can't really move the heads manually, but should be okay. We'll just plug in the power. Okay, power's in. Plug in the interface cable. There we go. This drive works. There we go. 96 track per inch, 80 tracks, and it's working. So far, we've had a really good ratio. Are those Torx? Yeah, that's a Torx bit. Do I recognize this drive? Let me look at the front. Kind of looks like a Neutronics, but it's a little different. Ah, okay, there it is. It's a Mitshubishi MF504C-368U. We've had a whole bunch of different types of drives. There's a date code right there, 1993. It's certainly dusty, isn't it? Look at this. Not a lot of jumpers. So drive change, DS1, DS0. Are you kidding? There's only 2 drive select jumpers? That's pretty rude. So if you want to use this on like a machine that's got 4 disk drives, like something that uses a Sugar interface, that's not going to work. There might be a way to, like, you know, just hot wire it from these little connectors here. SR, DC, there's the FG, I don't know, 1 and 3, whatever that is. And then these 2, SB and SS. Look at that. Prevent static discharge. Sure, okay. All right, it's got that stepper motor thing that's like kind of like a 3.5-inch disk drive. At least there's some grease on there and it's not incredibly filthy. We got some surface mount caps there. Do they look like they've leaked? This one does. So that right there could be causing an issue. I don't know, is that just dirt? 100 microfarad, 10 volts. Meanwhile, this one, 33 microfarad at 33 volts. So that could be a problem right there. This cable looks like it's not in all the way. Anyways, all right. Let's plug it in and see if it works. It's working. So this drive works well too. That is amazing. And I guess, you know, because wow, this is kind of a limited drive, as I said, because it's missing the extra drive select jumpers, but hey, anyways. All right, well, there we go. So putting this down on the pile, which I know you can't see, we are down to 9 working 5.25-inch drives. And then we just had this one drive right here, which was this TIAC right here. Remember, this thing spun, but it wouldn't read. That will be a future repair attempt. And we have 2 quick 3.5-inch disk drives left here. And these are probably just gonna work. One of these is a TIAC right here, TIAC FD235HF. I don't love this particular drive because it doesn't even have drive select at all, nothing. So you could like hot wire it. Oh, here we go. There's drive select 1 and drive select 0. So to change the drive select on this, you have to remove this little jumper link. It's a 0 ohm resistor and place it right here. So this allows you to have either drive select 0 or drive select 1. Some other strap right here, S4, S3, you know, who knows how this works. The older versions of these drives have a lot more jumpers available to them, and you could configure them to work on like Amigas and stuff by moving some jumpers around. And it's possible with this one, you could as well by, you know, reconfiguring these straps here. And any other straps? No, these are caps. Those caps could be leaky, but they're through holes, so that's a good thing. This thing is dirty. It's probably really dusty inside, but I wouldn't be surprised if it completely works because these drives are just reliable. Clean 3 times. Now remember, these drives run at 300 RPM all the time. There are some very specialized drives that run at a faster speed, but pretty much all the normal PC drives are always just going to be 300 RPM. Okay, need a disc. Here's one. I don't know what this disc is. Our pet records. Not sure where this came from. It is high density though. Pop that in there. Let's see how this works. 18 sectors, so double that is 36. Looking good. Try the other head. So we're on head 1. That's good. Head 0 is good. Go to track 70. It's looking good. Track 30. And it's looking good. Okay, so this drive works. I was gonna say, if you can read high density discs, you can read double density discs, same number of tracks and everything. It just runs at 250 kilobits per second, and the little switch that's in there is what determines the difference. I do like to write on this here. I'm just gonna put 1.44 and a tick mark, just so I know it's not like a 720K drive. Those are just pretty rare. Okay, so yeah, as we said, this is the drive we just tested, TIAC FD235HF. This one here, 235 HF. But see how it says 6291U? That's kind of like a sequence number or something like that. And see, this is A29, whatever, it's different. It's a different drive. Does it look the same on the bottom though? The layout is different if I recall here. So there's S4, S5, S3. Where are the drive selects? Oh, it's right here. It actually has jumpers. There we go. Drive select 0, drive select 1. You can't control the termination. You can't configure anything else. I definitely have other TIAC drives that look just like this that have way more jumpers, which allow you to configure it for the Amiga. And definitely it works. Cleaning disk time. Cleaning 3 times. Sounds like it's working okay. Now, I hope anyone watching this isn't like, hey, you're not testing like in DOS. You know, that doesn't show that it's fully working. I can guarantee you that like what we're doing here in IMD is all you need to do for testing disks. When it's working in here, it's working in DOS. For sure, 100%. Go, both heads, track 70, it's working, both heads. We're good, we're golden, fully functional. Get that off there. 1.44 and a tick mark. Alrighty, there we have it. So test and try. We have 2 working 3.5-inch drives. We have 1 bad TIAC 5.25-inch disc there, disc drive. And then we have all of these working 5.25-inch drives. They are all 1.2 megabytes. Keep grabbing these up here. So that's 3, 4. And we got 5. There we go. So those are like not TIACs. And then we got 1 TIAC double speed drive, 2 TIAC double speed drives, 3 TIAC double speed drives. That one has a red LED, the other 2 are green. And then we got 4, but this one's a single speed drive with a green LED. So yes, we got 9 working 5.25-inch disc drives, 1 bad one, and 2 3.5. That is a good haul, I gotta say. I am pretty pleased by that. They're all in here with a few loose screws. So there we go. I hope you enjoyed this video. Hopefully the camera's focusing on me and not these disk drives. Yeah, it looks like it is. I hope you enjoyed this video of me testing out these disk drives, test and try, scintillating content. But you know what? This is the kind of stuff that when you work on retro computers like I do and have, you know, lots of stuff, I need to sort through it and figure out what works and what doesn't work. And with this non-working disk drive, you know, I can try to make a repair video out of that. I mean, I have very low confidence I can make that drive work, but at least I know all these drives are good. Some need a little extra cleaning and whatever, but they're all absolutely working, which is fantastic. It really makes me excited, especially to get 3 double speed drives, confirmed working double speed drives that can run at both speeds. That means that these work great as 96 track per inch disk drives or 80 track drives in older machines like TRS-80 Model 3s and stuff like that can absolutely use these. And that is really cool. I smell a little bit of mustiness coming off these disk drives. My smell is not super good after human malware. It's mostly good, but I notice it's just a little bit less sensitive, I guess is the right word. The acuity is not quite as good as it was. Anyhow, if you enjoyed this video, I'd appreciate a thumbs up. If you didn't, you know what to do. Huge thanks to my patrons. Their names are scrolling up the side of the screen. They literally make it possible that I make these videos now, so that is amazing. They're rock stars. You can become a patron at the link in the description below, and patrons get early access to videos, plus the higher tiers get behind the scenes stuff like live streams and things like that. I've done one live stream so far, and that was really fun, actually. I think there was like 60 something people on there at the peak of the live stream, and this was like a last minute thing, so I was kind of shocked that many folks joined. Anyways, yeah, that is going to be that. So yeah, comment down below, subscribe, all the usual stuff, and stay healthy, stay safe. I'll see you next time. Bye.